Okay, so in the last video, we introduced the three main types of intermolecular forces: London dispersion forces, dipole-dipole forces, and hydrogen bonding interactions. So we're going to talk about these in more detail. London dispersion force is basically attractive forces between an instantaneous dipole and an induced dipole. And so I mentioned in the previous video, London dispersion forces occur between all molecules. They're very weak, but they can happen even if you don't have a dipole. So think about a hydrogen molecule, okay, H and H. That's an equal tug of war going on. That's a non-polar covalent bond. But there's still randomness, right? There's some randomness to where the electrons are. And at any instant, there'll be a slight negative charge on one end of the molecule and a slight positive. Very, very slight compared to a permanent dipole, but it'll be instantaneous. And it'll fluctuate, right? In the next instant, it could be reversed, and there's a positive charge here, a negative charge here. That's what we call an instantaneous dipole. And if there's an instantaneous dipole, which there is at any instant, that will induce the opposite dipole in the other molecule. So if this one had a negative charge over there, it's going to induce a positive charge over there because that will be energetically more favorable, right, for a negative and a positive to be together. And so this is going to cause the two molecules to attract with one another. And so that's fundamentally what a London dispersion is. It's random fluctuations in electron density that cause temporary attractions, okay? So you can see electrons were one way and then they went the other way. That caused a dipole, okay? And it induced a dipole in another atom, okay? London dispersion interactions can be quite strong if they are added up over a large area. And so if you look at a gecko's foot, okay, it actually all works based on London dispersion forces. And geckos can walk on a wide variety of surfaces. Doesn't matter if that surface has a dipole or not. And the way the foot works is if you look at it under a microscope, there's all these little fibers, okay, that really increase the surface area of their feet. And that basically increases the amount of interaction between their feet and whatever the surface is. That increases the amount of London dispersion forces. And even though each London dispersion force on a molecular basis is very small, these add up and allow the gecko to walk, up walls. And people have been inspired by this, and they've been able to make biomimetic artificial climbing devices. And so researchers at Stanford have done this. You can watch this video. But basically, they've been able to make this. Is just, you'll see the video. The guy is walking up a piece of glass, and he has these artificial gecko feet on, and it's pretty awesome. Okay. Dipole-dipole interactions. That's the second type of intermolecular force that we're going to go over. This is the attraction between permanent dipoles. So you need a polar molecule. And it's the same thing as the London-London dispersion, but they're much stronger because now you have a permanent dipole. So you have a plus and a minus. The plus side of one molecule is going to attract the minus charge of another molecule, okay, and vice versa. And so what we're going to do in the next video is we're going to ask this question, okay, do water and dichloromethane exhibit dipole-dipole interactions?